Stars are born, live, and ultimately die in a grand cosmic cycle. Some fade away gently, while others meet a violent and spectacular end. Among the stars of our universe, Betelgeuse stands out due to its immense size and unstable behavior. This red supergiant, located in the Orion constellation, has fascinated astronomers for centuries. Its fluctuating brightness, reddish hue, and unpredictable nature suggest that it is in the prepare yourself for an extraordinary celestial event that could soon unfold before our very eyes. Betelgeuse, a colossal red supergiant star situated on the fringes of our Milky Way galaxy, has been emitting signals that have both excited and alarmed astronomers. The James Webb Space Telescope has detected unusual activity from this aging giant, leading world-renowned physicist Brian Cox to issue an urgent warning. Could Betelgeuse be on the verge of an apocalyptic supernova explosion that would forever alter our view of the night sky? Let's explore the science behind this unfolding mystery and what it could mean for our cosmic neighborhood. Final stages of its stellar life. But what makes Betelgeuse so unique? And why are scientists paying such close attention now? At an estimated 764 times the size of our Sun, Betelgeuse is a true behemoth. If it were placed in our solar system, its outer layers would extend past the orbit of Mars, consuming Mercury, Venus, Earth, and the red planet in its fiery embrace. This sheer magnitude makes Betelgeuse one of the largest known stars, a defining characteristic of red supergiants. These titanic celestial bodies burn through their fuel at an astonishing rate, leading them to live short but dramatic lives in comparison to smaller, longer-lived stars like our Sun. Despite its enormous presence, Betelgeuse is a relatively young star, estimated to be around 8 to 8.5 million years old. This may seem ancient from a human perspective, but in stellar terms, it is merely a fleeting moment. Unlike our Sun, which has an estimated lifespan of about 10 billion years, Betelgeuse's immense size accelerates its evolution, propelling it swiftly toward its inevitable demise. The star has already undergone significant changes, evolving from a hot blue giant into the cooler red supergiant we observe today. Its deep red glow is the result of a lower surface temperature, approximately 3,500 Kelvin compared to our Sun's 5,500 Kelvin. This transformation has been documented throughout history, with records from ancient Rome and China indicating that Betelgeuse may have once been a yellow star before shifting to its current crimson hue. One of Betelgeuse's most intriguing characteristics is its fluctuating brightness. It is classified as a semiregular variable star, meaning its luminosity changes over time in distinct cycles. The primary cycle lasts approximately 400 days, while a secondary cycle spans about 5 years. However, unlike many stars with predictable variations, Betelgeuse occasionally exhibits unexpected and dramatic shifts in brightness, leading scientists to suspect complex internal processes at play. In late 2019, Betelgeuse experienced an event that stunned the astronomical community. The star suddenly dimmed to an unprecedented extent, a phenomenon visible to the naked eye. By February 2020, it had lost over two-thirds of its usual brightness, sparking intense speculation that it might be on the brink of a supernova explosion. However, observing Betelgeuse presents a unique challenge. Because it is located approximately 725 light-years from Earth, the light we see today actually left the star around the year 1300. Any significant changes occurring on its surface have already happened centuries ago, reminding us of the vast distances and timescales that govern our universe. Further investigation into Betelgeuse's Great Dimming Event, led by astronomers such as Andrea Dupree from Harvard and Smithsonian Center for Astrophysics, revealed a fascinating discovery. Using the Hubble Space Telescope, scientists found that the star had expelled an immense amount of material, which subsequently cooled and formed a dust cloud. This ejected mass temporarily obscured Betelgeuse's surface, creating the illusion of dimming. The sheer scale of this event was unprecedented. Betelgeuse had shed material equivalent to 400 billion times the energy of a typical solar coronal mass ejection. This phenomenon challenged previous assumptions about red supergiants, suggesting they might undergo massive ejections as they approach the supernova stage. The question remains, is Betelgeuse truly nearing its final explosion? Some astronomers believe that its demise is imminent, possibly within the next few decades, while others estimate that it could take another 100,000 years before the inevitable occurs. To gain insight into Betelgeuse's fate, scientists have turned to other supernova events for comparison. One such event is SN 2023 IXF, a supernova observed in the Pinwheel Galaxy, located 21 million light-years away. Discovered in May 2023 by amateur astronomer Koichi Itagoki, this explosion provided valuable data about the last moments of massive stars. Observing SN 2023 IXF has helped refine models of stellar collapse, offering clues about how and when Betelgeuse might meet a similar fate. Current scientific models suggest two possibilities for Betelgeuse's status. Some research indicates that it has already exhausted its carbon-burning phase, meaning it could collapse within mere decades. Other studies suggest that it is still burning helium, in which case it may persist for tens of thousands of years before reaching its end. Regardless of which timeline proves accurate, one thing is certain: Betelgeuse is among the most likely candidates for the next visible supernova in our galaxy. Throughout history, supernovae have played a crucial role in advancing our understanding of stellar death and cosmic evolution. Notable examples include SN 1006, the brightest recorded supernova, which was visible across multiple continents, and supernova 1987A in the Large Magellanic Cloud, which allowed astronomers to observe a stellar explosion across the entire electromagnetic spectrum. Each of these events has contributed to our knowledge of how stars die, enriching our understanding of the universe's ever-changing landscape. When Betelgeuse does finally explode, it will be one of the most breathtaking astronomical spectacles ever witnessed by humanity. A core-collapse supernova of this magnitude will release more energy in mere seconds than our Sun will generate over its entire 10 billion-year lifespan. The explosion will be so luminous that it will be visible even during the daytime, outshining every other star in the night sky for weeks or months. Such an event will not only captivate astronomers but will also offer an unparalleled opportunity to study the physics of supernovae up close. While the exact moment of Betelgeuse's explosion remains uncertain, its fate is sealed. It is a dying star on the brink of transformation. As we continue to monitor its fluctuations and unravel the mysteries of its turbulent life, we are reminded of the dynamic and ever-changing nature of the cosmos. Whether in our lifetimes or in the distant future, Betelgeuse's inevitable demise will mark a historic moment in our understanding of the universe. Until then, we watch and wait, gazing at one of the grandest celestial dramas in our cosmic neighborhood.